Let's do a little more today with exponents, talking about powers. This is kind of a funny title to today's lesson, but it's called Powers of Powers. And you'll kind of see why that's true here in just a minute. Continuing with the same objective we worked with for a few lessons here, understand and apply the laws of integer exponents to simplify expressions. So we've already learned about how to multiply and divide some powers, and now we're talking about some other things with powers as well. So learning some new rules today. So the first rule here is called the power of a power, which is kind of fun. The words here say to find the power of a power, multiply the exponent. So let's see what it means by power of a power. So this is the example they give here, 5 to the second to the third. So when you already have a power and you raise that to another power, so that's the situation we're talking about here. So let's rewrite this real quick, 5 to the second to the third. Let's think about what that means. That means 5 to the second times itself 3 times. So I want you to rewrite this as, what that means is 5 to the second times 5 to the second times 5 to the second, like that. So as you can see now, what we learned about multiplying powers, these all have the same base, and then we would just add these exponents together, right? So 5 to the second, 5 to the second, 5 to the second, altogether 5 times itself 6 times. The shortcut rule, though, the one that they're trying to get you to learn here, is that if you have a power to a power, this is a situation where you actually do multiply those exponents. So the shortcut way to do this would just be take the 2 times the 3. That would also give you 5 to the 6th. But, you know, if you need to write it out in the meantime to remember what that really means, sometimes that can be helpful still. Let's take a look at this. This is called power of a product. It says to find the power of product, find the power of each factor and multiply. So what this means really is that sometimes you have something in parentheses that's not just one power. Sometimes you have some things being multiplied. So in this case you have 6 and x squared being multiplied, and then in parentheses, that's what they are, outside those parentheses, you've got an exponent. And you need to remember that anything that you can consider to be a base inside those parentheses gets this exponent applied to it, even if it already has an exponent, okay? So what this literally means, again, I want you to write this out with me here, 6x squared to the third literally means 6x squared times, I'm showing times in a different way here, but that's okay, times x squared times 6x squared, like that. Okay, 6x squared times itself 3 times. So you have this 6 that's being multiplied, 6 times 6 times 6, and you could either rewrite that as 6 to the third, but today we're actually going to evaluate these. We're going to get, if it's a regular number, we're going to get what 6 times 6 times 6 equals. So you could write this as 6 to the third, or 6 times 6 times 6, I think, is 216, okay? And then you've got x squared times x squared times x squared. X is being multiplied times itself a total of 6 times. But, you know, you wouldn't have to write out like this every time. The shortcut way is to say, okay, this exponent of 3 gets multiplied, or gets applied to the 6, and applied to the x squared. X squared to the third is x to the 6th. And then you'd evaluate that 6 to the third, which is 216. So 216x to the 6th is your final answer. You can get that either by writing it out like that or just applying the rule. The rule is everything in the parentheses gets that exponent applied to it. So let's try this a little bit here and see if we can, and I may be using a calculator here a little bit, and you may want to make sure you have your calculator close by as well as we do some of these numbers that are some pretty big exponents. Some of them I may know, and some of them we'll just have to calculate out. I hate to get them wrong on the video here. So let's go ahead and do 8 to the third. So in parentheses, 8 to the third. And we're going to make that to the third. So this goes back to this first example that we did, where it's just one power, one base. So this gets that exponent applied to it as well. So 8 to the third would be 8 to the 6th. I'm sorry, not 8 to the 6th, because we'd multiply those, right? So 8 to the third times itself 3 times would be 8 to the 9th. We can also, we're supposed to evaluate these today. It says simplify, but it does not say to express using exponents. We're going to leave our variables with exponents because we don't know what they are, so we can't simplify those. But the regular numbers, we're going to go ahead and evaluate those all the way down to without an exponent. So we're going to do 8 to the 9th here. So 8 raised to the 9th is a big number, okay? So we're going to go ahead and write this whole thing out, and we'll put our commas in. This is good practice for writing, making sure we have our commas in the right place for big numbers here. So this is 1, 3, 4, 2, 1, 7, 7, 2, 8. I think I got that all written out there. So when you write commas in a big number, you count starting with the right, 1, 2, 3, and put a comma. 1, 2, 3, put a comma. So this is 134,217,728 for that one. So yeah, definitely going to need to keep a calculator close by for some of these here. So we got 6 to the 5th to the 2nd for number 2. So we're going to keep the base the same and then multiply the exponents. 5 times 2 is 10, so we're looking at 6 to the 10th. Let's see what that looks like. 6 raised to the 10th. Okay, get another big number here. So we write that as 604,66176. Put a comma there. 60,466,176 looks like. Okay, number 3 is k to the 7th, so in parentheses here, k to the 7th, to the 5th. So we're going to simplify that. We can't get this any simpler than just to rewrite this with exponents. Keep the base the same and multiply those exponents. 7 times 5 is 35, so this would be k to the 35th. It's a good thing that's not a real number, otherwise it probably wouldn't fit on the calculator. Okay, so we just leave it, if it's a variable, we just leave it with that exponent because we don't know what k equals. Number 4 is in parentheses 4p to the 3rd to the 4th. So this is one of those where we have more than one thing that's a base here, more than one thing that we could consider to be a base. We have 4 that gets that exponent of 4 applied to it, and p to the 3rd that gets that exponent of 4 applied to it. You know, you could think of this as 4 to the 1st power if you wanted an exponent with that. If you wanted something to multiply there, so 4 to the 1st times, or to the 4th, you could multiply those exponents and it would still give you 4 to the 4th. We'll simplify that down here in just a minute. We'll figure out what 4 to the 4th is. And then p to the 3rd to the 4th. So you multiply those exponents, you get p to the 12th. I think 4 to the 4th is 256, but let's just make sure. Yeah, 256. So we'll simplify that down to 256 p to the 12th. That's your final answer there. So again, if it's a regular number today, it has an exponent with it, we're going to evaluate that exponent. Okay, number 5 is, in parentheses, -2 m to the 7th, p to the 6th, to the 5th. All that to the 5th. So that means all these get an exponent of 5. So -2, because it is a negative number, we want to give it its own set of parentheses there to make sure that the negative stays with that. So -2 to the 5th, m to the 7th to the 5th. So multiply those and you get to the 35th. And then p to the 6th to the 5th. 6 times 5. P to the 30th. Okay, and then let's simplify this. -2 to the 5th. It's going to end up being negative here, raised to the 5th, because we have an odd exponent there. So -32, m to the 35th, p to the 30th. And we may get to the point where we don't rewrite the regular number with x and exponent first, but I think it's good practice just to show what that is first and then evaluate that. And then number 6 is 6x y to the 11th to the 4th. So everything in here that could be considered a base, the 6, the x, the y, all this gets an exponent of 4. It's all included in those parentheses. So 6 to the 4th, x to the 4th, y to the 11th to the 4th, power to a power. We learned today we multiply those, so y to the 44th. So now we just need to get 6 to the 4th. We've done 6 to the 3rd today. I don't think we've done 6 to the 4th. You have 1296. X to the 4th, y to the 44th. They stay with exponents because they're variables. So that's your final answer on that one. All right, we'll do some more practice with this in class, but until then, that's enough for the powers of powers.